Okay, this is the charge to mass ratio experiment. So we have a power supply and we have our apparatus. Now inside there are the coils, and here we have the electron beam, which, as we discussed, is in a circular motion, and that's where we discussed that the magnetic force on the electrons is equal to the centripetal force. So we have several different ways to do this. So we have a voltage supply, that's our potential energy that accelerates the electrons. And then we have a current that goes through the coils, which that is the source of the magnetic field that causes the circular motion of the electrons. So at this current point, it's reading 1.762 amps, and that's the current in the coil. And you can use that current or whatever value is given to calculate the magnetic field, which is given in your lab description. And here we can observe the voltage, 352 volt, and that is also needed in our calculations as we discussed before. So we can adjust the voltage here and see what happens to our radius of curvature, and we can adjust our current and see how that also affects this. Okay, so now we have some data.
Now this is current 1.4 ampere. This is voltage 148 volt, and the radius now is about 7. Diameter is about 7 centimeter. Next, I'm going to increase the voltage. What happened to the radius? Next, I'm going to decrease the voltage. Okay, so next I'm going to keep the voltage constant but increase the current. If I increase the current, the radius decrease. Okay, you think of why?